This is project 16 of Hacking with Swift. We're going to create a Safari extension, new in iOS 8, to add some cool code directly into Safari so that users can manipulate web pages using JavaScript. It's a bit like the Mozilla Greasemonkey extension, if you remember that, just for iOS. For more information, see the project website, hackingwithswift.com, where you can buy this thing as an ebook for just $3. Super cheap, and it contains tons more information to really deepen your Swift learning. Plus, you can buy this as a high-resolution video, and indeed the entire series as a book and videos. And of course, your support does help me make more videos like this one. You can always follow me on Twitter. I am at 2straws. If you have problems, questions, feedback, suggestions, whatever, get in touch. I will do my best to help you out. This is the first of 2 projects that are hard. Not because I want to torture you, but because your skills are now improving. We're over halfway through the series now. So the actual amount of code you'll be writing is small, but most of the code is quite dense. Sorry about that. That's just the Safari's extension system being quite tortuous in places. However, you will learn lots about Safari extensions, and you'll meet a new class called NS Notification Center. So let's get started. Go ahead and launch Xcode. Choose Create the New Project. Then from the menu, choose iOS Application Single View Application. Call it Project 16. No coordinator. Target a device. I'm going to choose iPhone for ease of use, but really you can do what you'd want. And Swift, press next, then save it somewhere. I'll choose my desktop. Fantastic. So there is some complexity. First up, we have to make what's called a shell app. Safari extensions are launched from within the Safari action menu, but they ship via the App Store inside a parent app. That means you can't ship an extension by itself, you must have an app alongside it. Now frequently these apps do very little, but it must at least be present. So there are 2 common ways to use the app component if it hasn't got anything more interesting. Firstly, showing help information, stick a web view or a label in there with some help. That's very, very common. Alternatively, show some basic settings, they can toggle to configure the extension to work right. That also works. We'll go with the first option. Although to skip lots of help text, I'm just going to put hello world in there. So open your main storyboard, drop a label in there, like that. Add the text, hello world, boom. Make it roughly the right size. There we go. I will center the text as well. Now just drag it so it's sort of centered inside the view. There we go. And you can go ahead and add some constraints. So I'm going to drag upwards and choose center horizontally, then drag to the left and say center vertically. These orange boxes mean it's the wrong size. As you can see, I've made it bigger than it needs to be. It won't be like that when the code runs. It will resize it. But you can, if you want to, if the orange lines annoy you, go down here and choose update frame, like that, and it will just shrink to be exactly correct. That is our entire app storyboard complete because I'm not doing any work in there. It's your parent app, your shell app. You can put whatever you want in there, buttons, settings, web views, whatever you want. We are going to focus on the extension from here on in. Now, extensions are basically miniature apps in their own right. And that, as such, they need their own space in your code. Now, that doesn't mean you can't share code and resources between your extension and your app, just that it's not automatic. So we are going to get started with a fresh extension. So go to the File menu and choose New, then choose Target. We've not used this before. When you're asked for a template, you can choose Application Extension. As you can see, I've been using Apple Watch stuff recently, never mind. Application Extension, and there are various options here. And the one we want to choose is called Action Extension, the very first one. And then go to Next. You need a name for it. I'll just call it Extension. It's part of course, Project 16, as you can see here. It'll ask you, does it present a UI or not? I'm going to say yes, it does, and then press Finish. And it appears down here under Extension. It's separate from your project, which means it has its own storyboard, its own code, its own supporting files, its own info plist. It's all separate. Now, you may have been asked when you run your, when you create a target like that, do you want to switch to the scheme for the extension? Press yes, and then choose Do Not Show Again. As you can see, I've switched to extension already. And that means when you run the code, you'll actually run the extension, which is perfect for our needs right now. You can change that by clicking here and choosing the project, but all it'll do is launch hello world, so it's rather pointless. Leave the extension on. That's perfectly fine. Now, so here are our files I want to care about. You'll see main interface storyboard, and that is for the extension. It's different size. It's got stuff in there. It's got a navigation bar. It's got an image view and some code. The code in here is pretty much all new, and I have to admit it's pretty nasty. It's not lovely work from Apple in terms of nice and easy API, but that's okay because I'm going to walk you through what it does and we'll simplify as much as we can. I would say when you finish this project, create another one and have a look at what this code does. Once you understand what it's trying to do, have a look at Apple's code, because Apple's code is more resilient than the one I'm going to use. Mine is much simpler to understand. So I'll show you the easy version so you understand what it's trying to do, and then have a look at what Apple's is doing, and it does the same thing, just with more resilience behind it. It's a bit nicer, well, a lot nicer, let's face it. So the way extensions work, the reason why this code is complicated, and there's more complication to come, sadly, trust me, there's quite a lot of complication to come. It really is a hard project. The reason it's hard is because your extension doesn't talk to Safari, and Safari doesn't talk to your extension, because that's risky. You could find some sort of evil hole in Safari and cause problems for everyone. So it doesn't talk to Safari. Instead, Safari talks to iOS. iOS talks to your extension. So it sanitize the data and make sure it's safe, and passing data to the extension and back to Safari from the extension when it finishes. So what we're going to go do is all this code, just delete it all. I mean, really, up to super view did load. Again, please look at it later because it's very good code. It's just complicated for now. We're going to make it much simpler to begin with. So just leave the view did load in there. Please also remove this image view outlet. We don't want that either. Instead, we're going to make something much simpler. So, in view did load, the first thing we're going to do is pull out extension information that's passed to us. It is given to us using extension context. You see, if you do that, you'll see it in there, extension context. So every view controller has an extension context. It is nil, empty, if you are not an extension. Otherwise, it has a value. You can start using it. It gives you information about the environment your extension is running in, specifically what was passed to it by Safari. And we have to unwrap that very carefully because it might contain lots of information, will contain lots of information that we have to pull out and parse in a meaningful way. So we're going to say if let input item equals extension context dot input items dot first as ns extension item, like that, and that will give us an ns extension item which contains information about our extension. So it will tell us, for example, what has been given to us by the user to work with, and the user in this case happens to be us as well because we're passing in JavaScript. Oh, you'll see it in a minute, don't worry. It gives us information about the extension. Just live with it for now. And we're pulling out the first one because we only passed one bit of information through. Apple's code is a bit smarter, but this is good enough for now. Then we want to pull out an item provider. This is what will give us the actual item data. This gives us lots of data. This gives us just the item we ask for. So we're going to say if let item provider equals input item dot attachments, like that, dot first as question mark ns item provider. So pull out the first attachment from the first input item and then load its data. Now it's whinging slightly here because we need to, this is optional, so there needs to be a question mark in there because it's optional. It may not exist, obviously. So we need to load the item. Now this is, it's required and it's complex because if you're passing lots of data, you might not want to parse it immediately. So iOS doesn't have to copy it all across, all, say images and stuff or text, lots of text perhaps. It only loads it when you actually ask for it. So it only converts it from the Safari data when you actually require it. So we're going to say item provider dot load item for type identifier. Now the type identifier is, in this case, KUT type property list. I'm going to hide some things here so you can see what I'm doing. So load our item using property list, options nil, completion handler is a block, which means we can end that and use trailing closure syntax to say unowned self in. But it will give us two parameters. It'll give us a dictionary of things it found and any errors it found as well. If something went wrong, it'll get an error back. And that's a closure, and code will happen here, like that. Now, what this means is this will execute. Our code will carry on running down here, run here, and eventually, when it's finished loading the data from Safari, it will call this code. That's why it's a block. So it won't hold back, that's why it's a closure, sorry. So it won't hold the main thread back while it's executing. So it is complicated, but those 3 lines of code are all it takes to get data from Safari. Apple's 10 or so, very, very clever, but unnecessarily complicated at this point. Now a property list, a P list, we have one of those already. It's over here. We always did have one. And it holds data about our extension, or in the case of our app, about our app. It's just key value, key value, key value. And some are arrays. This is an array here with 1 key and 1 value. This is another array. And you can see it's supported interface orientations. That's the thing we're setting up here. It's a way of saving lots of data inside iOS into a file. And this particular type is used when we're passing lots of data from JavaScript, which is what we're going to do inside Safari. So that will say, get the data from Safari, put it into this dictionary. If anything went wrong, put it in error, and then run some code here. That's what it does. I know it's significantly shorter than Apple stuff, which is great for learning, but it does do less smart stuff than Apple's code. So by all means, look at their code later and see what it does and why, once you understand how it works. But cunningly, the project does nothing so far. It's all this nonsense, NS extensions, NS item provider, Nothing's actually happening yet, because Apple's default project is designed to handle images. We don't want images, we want text stuff, because we want to do JavaScript. So what do we want to get? Well, inside the extension view, select info plist, and you will see NS extension is a set of values. It's a dictionary with 3 items, one of which is another dictionary with 1 item, and then 2 more down here, and you can open that up as well and see what it's doing. And this describes the extension to iOS in ways that let it know how it can be triggered. Particularly matters to us is NS extension activation rule, the one that's selected right now. This says to iOS, when should this extension be available? What we're going to do is we're going to change that so it's smarter, because right now it just means it's got true predicate, which means show it absolutely everywhere. This extension supports absolutely everything. It's not for us, trust me, we only want to support some things. So change this string using the arrows to be a dictionary, then press the plus sign to add a value. There we go, add a value. Is it inside there? I think it is, can't tell. No, it's not, I misclicked. Let's try that again. Go away you, open that thing, add a value in there please, there we go. And you want to call this thing NS extension activation supports web page with max count. Brilliantly named, Apple. They really are utterly descriptive. And we're going to make it a number, and the number should be 1. We support 1 web page. So this tells Apple this action extension should appear inside Safari when we're looking at a web page. That's what it means. And it will understand that, and it will work only in those environments as opposed to every possible environment, which is good. We don't want to receive images or anything else. Next up, select the NS extension attributes line, that one. Now click plus. You'll see new item again underneath that one. And we want to write in here NS extension JavaScript pre-processing file. It's all text-based, I'm afraid. I don't realize there's a real chance of buggering up this entirely by writing the one letter wrong, but we'll stuck with that, I'm afraid. exactly like that. NS extension JavaScript pre-processing file. Because this is where things get interesting. We get data from Safari by first executing some JavaScript. That's a wholly different coding language, if you want to call it a language, more sort of buffed up dialect, but anyway, in Safari, and then passing that data to our app, which means we get to run scripts on the web page to do whatever querying we want to do and get the results to our app. So for the file, I want to insert in here the word action with a capital A. This tells iOS that our extension is going to be called using action.js. A file will create shortly. And it'll be in our app bundle. It will find that, it will run that script, and then use the result of that script to pass it on to our actual extension code. Do not write action.js in here. It should be just action. iOS appends the .js itself. So we haven't created the file yet, of course. So what I want you to do is right-click here in supporting files and say New File. Then let's look around, and we'll just want to choose other empty. You know, there's a empty file. There's nothing at all. Let's face it. And for a name, enter action.js. Again, capital A. Your OS X system is not case sensitive, meaning that action lowercase a, action uppercase a, same file. iOS is case sensitive, so you cannot do that. Make sure it matches the text for the pre-processing file key. So action.js with capital A, and there's the file. Now again, as we did HTML before with the petition stuff, this is not hacking with JavaScript. I am not going to teach you JavaScript. I'm going to give you the JavaScript, and you can modify it later. I'll give you the briefest idea of what it's trying to do, but it is quite messy, I'm afraid, because this is Apple's requirements, sadly. There's not a lot of it, and it looks like this. So var action equals function, parentheses, open brace, close brace, semicolon. Action.prototype equals open brace, then run colon, function parameters, open brace, close brace, comma, finalize, colon, function parentheses parameters, open brace, close brace, and then close brace, end, like that. That is the basic structure of our object. And finally, we want to say var extension pre-processing JS equals new action. That should do it. I realize this is hideous. I know it's hideous. Firstly, because it's JavaScript, because it's not particularly pleasant language in the first place. But second, this Apple requires it to be exactly like this. And there's a reason. This contains an object called action, which gets assigned to, well, it hasn't got objects in JavaScript. It's an object-ish sort of thing, which is called that, which is Apple's requirements. Apple's stuff will find that variable and call run on it, which means do your stuff before the extension is run, and finalize, do your stuff after the extension's finished running. So Apple expects the code to be exactly this. I may have messed this up completely with a typo in one random bit, and you may do the same. So by all means, grab a screenshot, copy and paste the text as much as you need to. Or of course, if you buy the book or the videos using Gumroad, you do get the source code included. But even after all this work, your extension still does nothing, and I can only apologize. I told you it was complicated. Let's get on to the real stuff. Let's make sure the communication is working from Safari to our extension to make sure we just know everything is set up correctly. Let's face it, I probably have screwed something up. You may have done so too. So we're going to modify this file, action.js, to send two pieces of data to our extension. The URL the user was on and the title of the page. So in this file, modify the run function to be this. Parameters dot completion function, then open parenthesis, open brace, quote URL, quote, colon, document.url, then comma, quote title, quote, colon, document.title. And then you need to end the brace, end the parenthesis, semicolon, like that. This is a really, JavaScript is such a murky language, bluntly. It is really impenetrable sometimes for some reason. What it means is this thing creates a dictionary where the key is URL, the value is document URL, key is title, value is document title, and it passes it to this method called completion function. This thing is passed to us by Safari automatically. Apple expects exactly that. It calls the magic method on Safari, which means pass this data to my extension. That's what it means. Now that it's being sent from JavaScript, data will be received in Swift, which is fantastic. So we can go back to the action viewcontrol.swift, where we have, let's take out run here, that's irrelevant, where we have code here, this line. Hopefully now we're receiving data from the extension. If I haven't muffed something up along the way, this should work. So firstly, you can see we're receiving a dictionary and error. These realistically, they are dictionary is an NS dictionary, not a Swift dictionary. This is the equivalent of NS string to Swift string. It's basically the same thing, but NS dictionary has some helpful behaviors. Specifically, you don't have to declare its data types. So in Swift, you have to say, let foo equals int colon string, right? To know exactly what the key is, exactly what the value is. In NS dictionary, you don't have to do that. It can be any kind of key, any kind of value, and you can mix and match freely. You can have some strings, some integers, some dates, some custom classes, which makes it very easy and very unsafe at the same time when you're using it. Fortunately, this is Apple passing it in, so we're not too worried. We know it's safe. So what matters is we're going to say let item dictionary equals dict as NS dictionary. Make it clear we're getting a dictionary out of here. Then we're going to pull out a special key that Apple gives us. This is called NS extension JavaScript pre-processing results key. Really catchy, Apple, thanks for that. So let JavaScript values equals item dictionary, that NS dictionary here, with the key NS extension JavaScript pre-processing results key, that one, massive long thing. And then again, cast that to be another NS dictionary. So this will contain just the values from our JavaScript. And what we're going to do is, just to make sure it works, we're going to say println JavaScript values, like that. Println is a Swift function built in, which will print things out to the error terminal window down here in the bottom of your thing. So before I explain what the code does exactly, let's go ahead and run it to make sure it works. So when you press run, this happens. It will ask you how you want to run it. So wait, it's thinking long and hard. Eventually it'll find Safari. Press Safari now and go to run. Launch a web page. I'll choose, say, Apple. Boom. Then go to the action menu. Ignore this stuff here. It's Apple's own mistakes being printed out. And you'll see our extension here. If you don't see it, go to more and look for it. But it does appear by default for me. You can enable it or disable it there. And then just select it. Like that. And, oh, it's crashed. Fantastic. We don't want to crash. Maybe yours didn't crash. Because I'm being slow. See that? See, I'm just being slow. I took out that IB outlet thing without clearing up the interface. Sorry. Apologies. I deleted the IB outlet from the code. So to recap, it was up here in IB outlet. And did not delete it from here. So it's getting angry at me. Sorry. Delete that. Delete that. Silly letter anyway. Let's try that again. Let's try that again. Run again. Choose Safari. Don't crash this time, please. Great. There's apple.com. Action. Extension. Boom. Big white screen. But in this thing, we can see it received successfully. URL apple.com. Title Apple, which means I have successfully not made a single typo apart from that crash in typing all those long strings into the info p list. We are receiving data in Swift from Safari. Now, if you know JavaScript, you will know at this point you can put all sorts of document querying things in here. In fact, I have an app called View Source. Go ahead and buy it, just $1, which passes in tons of information from Safari. It passes in the entire document tree, all the images, all the JavaScript, all the CSS, so it can be queried later. And you can do lots of great stuff like that just by writing JavaScript in here and then parsing it in Swift later on. So this proves we have our code working correctly from JavaScript to Swift, which is great. So back in Action View Controller, let's look at this just again. So we have these horrors here to unwrap the data from JavaScript. Sorry about that. That's just Apple's API being horrible. Make it NS dictionary so we can work with it. Pull out the exact key we're looking for, make that a dictionary, and then just dump it out using println, which is what this does. It's printing out nicely as a dictionary. So again, I've talked previously about how Swift string can be used interchangeably with NS string. Swift has an array type that can be NS array. Those two are the same. And Objective-C's version of the Swift dictionary is called NS dictionary. And it's very, very nice to use when you have to, but only if you absolutely have to. You know, a lot of things coming from Apple will be a variety of dictionary stuff. So just use NS dictionary for that. Otherwise, by all means, use Swift dictionary. It's much, much nicer. So it's time to do something interesting with this information. So back to the storyboard. I've obviously killed the, wrong storyboard. I've obviously killed the image view now. If you've not done that, do it now and zap the IB outlet as well. Then let's embed that in a navigation controller because they're awesome. So editor, embed in navigation controller. Fantastic. Thank you, Xcode. Make some more space. There we go. And now we're going to use a new UIKit component. You already met UI text field. That one for single line text. We're now going to use UI text view. So select one of these, drag it in, let it occupy the full screen, then let go. You'll need to zap all this lorem ipsum text it has by default, like that. We can add automatic layout to this using auto layout by going to editor, resolve, select text view first, like that. Editor, resolve, auto layout for us, and it will just add in the constraints. So editor, auto layout, add missing constraints, boom. So it sticks to the edge of the screen. And that's everything in Interface Builder, but we do need to have an outlet. So please add an outlet for it using Assistant Editor. So let's do in here, let's grab that and put it in. Outlet, we'll call it just text view. Actually, no, let's call it script. I think you're ready for real variable names now. So go ahead and add the outlet, and we are done in the Interface Builder entirely. So we can go back to Standard Editor, and then open up Action View Controller.Swift. We're going to store the data that gets passed in. So we'll say var page title equals quote quote, var page URL equals quote quote. And then we're going to store those because they're being passed in by Safari inside our closure. And we'll use the page title elsewhere. And the URL is down to you to use for your own improvement. I'm just passing it in as an example. So we're going to assign those in here. Rather than using println, we're going to add them in here. So let's do in here self.page_title. Of course, self is required because we are in a closure. Equals JavaScript values title as string. This is an NS dictionary. You've got no idea what's coming out, so you must do as string. Self.page URL equals JavaScript values URL as string. And then using GCD, we want to update the user interface. And of course, this closure can be coming in at any point on any thread. We don't know. We want to push it to the main thread so we know it's safe to update the user interface. So you've seen this before. Dispatch async, dispatch get main queue. Then all we want to do is say self.title equals self.page title. So we'll set the navigation bar's title to say Apple or whatever website you're on. So it updates our two titles when load item for type identifier returns. Then updates the navigation bar like that. Now you may have noticed this is a closure, trailing closure syntax, but I have not written unowned self in. That is intentional for a change. That's not a Paul Hudson screw up. And the reason for that is we are already inside a closure, this one. And that closure already has unowned self. So that self is already unowned by this point. It's not required to have it again. Don't have to do it twice. So we can now, at this point, immediately make our method useful, our extension, useful by modifying this done method down here. I've been ignoring it all along. It's been there since the very first minute. and we can call that, and it means it will return back to Safari and pass information back to Safari to do something interesting. So originally it was called by an action in a little navigation bar that Apple puts in there in possibly the worst Xcode template I've ever seen. Thanks, Apple. Instead, that's gone away now, so we're going to create a new UI bar button item in code. So up here we're going to say navigation item dot right bar button item. You've done this so many times by now. You're a Swift Pro. UI bar button item. We're going to use the system type done, calling self with action done, like that. That's just the method name down here, done. And right now it has one line of code. Self extension context force unwrap complete returning items bleh, stuff. And all it's doing is it's just passing back the things that were passed in. So whatever you receive, it passes back, which is it's a good enough test, but it's not good enough to make the thing actually work. Calling this method here on the extension context terminates our extension, hides it again, and returns back to the parent app. And when that happens, action.js will have finalized call on it, with these parameters being whatever you passed back from your extension. So to make this work in a slightly smarter way, we want to return whatever the user typed into our text view, the script text view. We have to create a new NS extension item that will host our items, then create a new dictionary containing the key custom JavaScript. This is our key that we use in action.js to read stuff. Put that dictionary inside another dictionary with Apple's key, NS extension JavaScript finalize argument key. Then wrap that whole thing inside an NS item provider object with the type KUT type property list. Place that into our extension item with attachments, and then call complete returning items. That seems like it's a massive amount of work, really, really hard, but actually all we're doing is unwrapping or rewrapping what we did here. So we have a dictionary here, we put that inside another dictionary with a special key, put that inside an item provider, put the item provider inside the input item, which is an extension item, and pass that back. So it's essentially this code in reverse. So even though it seems hard, it's really not that bad. So delete the comments and write this: let item equals NS extension item. And then let web dictionary, the thing we actually want to pass back, this should be a dictionary containing another dictionary, like I said. So the Apple's key is called NS extension JavaScript finalize argument key, JavaScript finalize argument key, colon, that's its key, and the value should be another dictionary containing other stuff. In our case, it's the custom JavaScript key, with the value script.text, so the value of our current script text box, like that. End both dictionaries. Then we attach that to the item. We say item.attachments equals an array, which it must be, which includes web JavaScript, web dictionary even. Wait a minute, no, I've missed one step out here. Extension item, I've missed the item provider. Sorry, I'm being slow. We have to wrap this thing inside this thing, NS item provider. Duh. So, try that again. Let custom JavaScript equals NS item provider. This takes an item, and our item is the web dictionary. Identifier must be KUT type property list. So it basically unwraps what we had here. Then we can attach that to our item. We say item.attachments equals custom JavaScript, like that. And finally, we return the item. So we're going to say self.extension context.complete request returning items. It needs to be an array, so we'll say bracket item, an array of one thing, our item, completion handler nil. That is all the code, quite a lot of code, but that's all the code, fortunately, required to send data back to Safari, at which point it will appear inside the finalize function in action.js, here, this bit, just here. From there, we can do what we like with it, but in this project, the JavaScript we need to write is remarkably simple because we can pull the custom JavaScript value out of the parameters array, then pass it to a special JavaScript function called eval, which executes any code it finds. So what we're going to do is we're going to say in here, var custom JavaScript equals parameters, then our key, which was custom JavaScript. Then pass that to eval custom JavaScript, and it's done. That's it, really. Our user's written the code in our extension, they tap done, it gets passed back to Safari and executed straight away. So we can give it a try. Now, press Safari again. That's fine. There it runs. There's Apple. Press here to launch our extension. Type in there, what should we do? Alert document dot title, like that. And that essentially it shows an alert box, a message box with the document's title in. Press done, it dismisses, and up pops Apple. So it is working correctly. This title here comes from the web page, that thing there comes from our extension. So you can now go ahead and let your users do any code they like. This is just like the Greasemonkey extension for Firefox, or I think before that, yeah, it's always been Firefox, which it lets users create their own JS libraries for various websites. It's really, really cool. And we've just made that in Safari. But it has a problem. It has a problem. And the problem is, what if your users are prolific JavaScript coders? And this is where the project goes from hard to a bit extreme, sadly, but I'll explain why. If they are prolific coders, they're going to say, do stuff, then do stuff, then do some more stuff, and yeah, functions, yeah, cool, I love JavaScript, yeah, awesome, and wait a minute, where's my text gone? What's happened is, we are now typing behind the keyboard. I can literally scroll, and I can't get to my text. I can't see it. I have to insert like loads of new lines just try and see my text, because it's so far down. It goes right down to the bottom of the screen, and this is a problem, and it breaks our app. Now, if you are running with what's called a hardware keyboard on iOS, or a virtual hardware keyboard, it will look like this. You choose hardware keyboard, turn it on like that one. There we go. You won't notice a problem. You think, oh, this is fine. This thing works brilliantly. But it's only when the actual keyboard appears, Command K, that the problems kick off, because we are not resizing the text to you so it goes beneath the keyboard. Now, you would think that iOS does this for you, and it does not. It is so frustrating. This is a really basic thing. It's existed since day one, and it's a real pain. And I have seen so many ways of working around this, and none of them are easy. And often half of them don't work anymore, because things change all the time. Like, this quick type bar appeared where you can sort of type by tapping things and make whole sentences by just tapping on words, which is obviously pretty cool. That's new in iOS 8, and you can actually swipe to show and hide it. And a lot of folks had code that handles the keyboard being shown, but not the quick type bar appearing or disappearing. So I've seen tons of code out there, and none of it's easy, or very little of it's easy, and very little of it actually works in all possible situations. For example, someone's code might work, but then not work when you rotate. It doesn't correctly resize, or doesn't work correctly if you connect a hardware keyboard and then unconnect it, or disconnect it, sorry. So it's a bit of a pain. So I've tried to put together a solution that copes with all possibilities and requires as little code as possible. So it might be imperfect perhaps in situations I haven't seen yet, but it does do the code in very, very short amount of space, which is what we want to do. So to do this, we're going to use a new class called NS Notification Center, which is really awesome, because behind the scenes, all the time, iOS is sending out notifications to anyone who cares about it. The keyboard appeared or disappeared, the application moved to the background, as well as anything we post. There are lots of notifications flying around the system all the time. And we can ask for ourselves to be an observer for certain notifications. And the method we name will be called whenever that notification occurs, and will even be passed useful information. So when working with keyboards, the ones we care about are UI keyboard will hide notification, and UI keyboard will change notification, will change frame notification. And using these two, we can monitor keyboard changes and respond appropriately. So the first is sent when the keyboard's finished hiding. The second is called when the keyboard state change happens, including showing and hiding, but also orientation and quick type and more. And you might think, well, why do we need hide? Because change covers hiding. It does, but in my testing, it's not enough just to catch will change. You must catch both, otherwise the hardware keyboard doesn't work very well. Extremely rare case, but we might as well be sure. So what we're going to do is go to our view controller. Then in view did load, we're going to register ourselves for notifications. So in here, you want to say let notification center equals ns notification center dot default center, like that. And that gets access to the standard built-in notification sending and receiving thing. So we're going to say notification center dot add observer self. We want to watch stuff, and we want to call the method adjust for keyboard colon. The colon meaning this thing takes a parameter. The name of the thing we want to watch is UIKeyboard will hide notification. And for the object, this means who should be sending this message? Nil. We don't care who's sending it. Like that. Then copy and paste that line. Let me hide this left pane so you can see a bit more. Copy and paste that line, and then also call self's adjust for keyboard method, but this time we want UIKeyboard will change frame notification. Again, object nil. So when the keyboard hides, or when it changes in any way, including hiding, you want to call the adjust for keyboard method. Now, the parameter it takes, this colon thing, means it takes one parameter, and it will include the name of the notification as well as an NS dictionary of stuff. Lots of things that are interesting. And that's actually contained in another block called user info, which you'll see in a moment. And inside there, we'll find things like, what was the keyboard's position before it started? What was it after it started? How long will the animation take and stuff? And it's really, really cool because we want to use those numbers inside our code. Because Apple will tell us, listen, the keyboard is now this big, the keyboard is now this big. And you want to use these numbers. Don't, try and hard code numbers in here, because the keyboard can change, of course. They can add things like QuickType whenever they feel like it. Users can switch to massive Chinese keyboards. There are some huge Chinese keyboards you can use that take up more space. And of course, there are custom keyboards now that take up even more space. So you have to accept the numbers from Apple. Don't try and figure out yourself. So one of the interesting quirks, and I use those almost in air quotes, one of the interesting quirks of Objective-C was that arrays and dictionaries could not hold structures like CGRect and CGPoint and CGSize. So Apple had this weird hack workaround value called NSValue, and that essentially wrapped up structures like CGPoint, like CGRect, just so they could go into dictionaries, bluntly. And that's what will happen here. In our NS dictionary from Apple, we will get back lots of unusual stuff we must convert to actual real stuff because they've been wrapped up in these NSValue things. So, it's not a lot of code we're going to write, but it is complicated. And I'm afraid that is part of the course in this project, it seems. That is life. So here is the method we're going to add. Put this before done somewhere. It's called func adjust for keyboard. It takes a notification, which is of type NS notification. And that's what will be given. Lots of stuff from Apple. And we want to pull out the user info key. That's the stuff we care about. What information do we have about the notification, specifically how big is the keyboard and so forth. So we'll first unwrap that, or pull out, by saying let user info equals notification dot user info force unwrap. It definitely exists. Then we want to figure out where the keyboard will end up on the screen, like this. Let keyboard screen end frame equals, this requires some thinking, parenthesis, user info, bracket, UI keyboard frame, end user info key, bracket. And the reason for this parenthesis here is because we have to typecast it as NSValue, which is Apple's wrapped up object type to go inside its NS dictionaries. So now that says, get this thing, consider it an NSValue, and now we can say, give us your CGRect value. What is the rect, the frame, the XY width and height of the keyboard? So it's a bit of a horror, that line, but that's the way Apple's things work because of Objective-C not being able to store rectangles, frames, sizes, and points, and so forth in dictionaries. But there's another quirk here, which is the way this value comes to us. It comes to us as a screen value, which does not take into account things like rotation, which is very unpleasant. Fortunately, that can be converted for us. We can ask our view to convert that. So we'll say let keyboard view end frame equals view, our view, convert rect. And you have various options here. Please choose rect from view, like that. The rect should be keyboard screen end frame, and from view, view.window. So it'll handle the rotation sizing for us, which is good. And now comes it is kind of a hack, but it makes it work correctly with the hardware keyboard. If we have received explicitly the will hide notification, we must hide the keyboard fully, or at least readjust the text view fully. So if notification.name equals UI keyboard will hide notification, then do stuff, else do other stuff. Now what we're going to do is modify the content inset of our text view. Content inset, if you imagine the frame of your thing, the actual size of it on the screen is this big, you can say, I want to inset the content by so much. The frame stays the same, but it acts like it's smaller inside the frame. And this makes our life much easier because we don't have to move things around, we don't have to adjust constraints, that kind of horror. We just have to say, just inset your scrolling slightly. That's what we're doing. So if it's will hide, we have to clear that entirely, make it no insets whatsoever. So we'll say script.contentInset equals UI edge insets 0. No edge insets. This is a new data type, but it's quite dumb. It just holds insets for left, right, top, and bottom. Otherwise, if we are changing the frame somehow, we want to say script.contentInset equals UI edge insets, make a new one, top 0, do nothing, left 0, bottom should be the height of the keyboard. So we say keyboard view end frame, not screen end frame, view end frame dot height, and right 0. So this will knock in our text view so it scrolls only as far as the bottom, the top of the keyboard. We're going to do 2 more things in this. Well, actually 3 things, but 2 of them. It's 3 lines of code, but yeah, there's 3 things we'll call it. Firstly, content inset adjusts the space given to content, but it does not change the scroll bars. You can change these independently. You can make the scroll bars be any value you like, which is helpful because sometimes you might not make it reflect the layout of your page more precisely. But in this case, we just want to make it match the content inset so it looks correct. And that's done by saying script.scroll indicator insets, and all we're going to do is assign script.contentInset. So set it here to the right thing, just copy it into there. Then we're going to move our scroll view, our script text view, so the user's text is visible. If they were typing and the keyboard, if they click to type, the keyboard appears, it may overlap where they were, which is very annoying. To do that requires 2 more lines of code. First, we want to find where the user is currently selecting inside the script. So we'll say let selected range equals script.selected range. Then we will say script.scroll range to visible selected range, like that. So find out where they were, then scroll to make sure it's visible. And this takes into account content insets. And now let's try running the program because you'll see something interesting happen. Press play, choose Safari, and then run. You will see the Apple site, press the action button, go to extension, our text view, and when you tap to select it, now we're typing absolutely nowhere. Let me try that again. There we go. Fantastic. We're now typing underneath the navigation bar, which is even worse. So we actually made this worse by using our adjustments. So we are typing underneath there, which is just awful. So the reason for that is because of the way our auto layout configuration is. we're going to make one very, very small change. And it's brilliant because it asks the auto layout to take into account the bottom of the navigation bar. So it keeps the text view always visible regardless of where this navigation bar is. So to do that, go back to main interface storyboard and bring up your inspector palette on the right here. You will see top space to super view for your text view. Select that and zap it. It goes orange because it's missing a top space constraint. Now control drag from click text view to top layout guide and choose vertical spacing. You'll see it here with -64 by default. Just double click that and change -64 to be 0, which means stay beneath the navigation bar, that top layout guide, at all times. And that's the last change. You can go ahead and press play now. Yes, fine. It will again launch Safari. Again, you must choose the action button, and again choose extension. This time, all being well, when you tap, it stays beneath the navigation bar correctly. And as we type, I have to use the actual keyboard, it looks like. Looking good. All this amazing JavaScript. And it has a scrolled correctly inside the space allocated for us. And if you change that, it will still scroll correctly. It adapts itself automatically. If we show and hide the hardware keyboard like that, it adjusts and scrolls automatically so the user's code remains visible when they're typing. You can try this if you like without the little hack in place for will hide notification. If you take this out, if you don't believe me, it's required. Take it out and then don't call it up here. Let's just call will change frame. And best of luck to you. See if you can get it working. Here it is running in Safari again, this time with the change. And I'll go to extension, and I'm going to go ahead and hardware keyboard on, type some awesome stuff. Brilliant. And look, it has not correctly put it back to where it used to be. It's changed. I see the frame is full size, but the content inset and the scroll inset haven't changed correctly. It really needs that hack in there. It could be a bug from Apple, it could be just some flakiness in my code somewhere, but I've tried to keep it as simple as possible. So do put this little hack in there to keep it nice and simple and make it work. So this has been a complicated project, I know it has. Sorry about that, I hope you're not too disheartened. Extensions are new in iOS 8, and I do hope they get a bit easier to make in the future. Perhaps some slightly nicer example templates from Apple would be good. But developers are still trying to figure out how they're used and what they're good for and what cool things can be done with them. So perhaps you might be the one that makes a breakthrough extension. I have made one already. Like I said, it's called View Source. It's on sale for $1, and it's great for web developers. And I have to admit, the code isn't particularly pleasant to work with. I don't think any of this did load method is pleasant, particularly not the text view adjustment stuff, but that's just the end of everything, not just extensions. But you have at least got a project here you can build upon, particularly if you understand JavaScript. You can go ahead and modify that and do more cool things. For more information, please see hackingwithswift.com or go back and make another extension, because like I said, Apple's code really is much better than mine for doing very, very thorough examinations of the extension item provider. You can buy this video as a high-res video. You can buy it as an ebook with packed full of information. Just costs you $3. You can buy the whole series as books and videos and really support my work to make more videos like this one. Alternatively, follow me on Twitter. I am @2straws. If I have time, get in touch. I'll do my best to help you. Have fun.